Have you ever met someone who seems to have a completely different personality depending on who they're with? One minute they're the life of the party, and the next they're quiet and reserved. Well, in the world of physics, there's a tiny little character that has puzzled scientists for over a century with its own kind of multiple personalities. I'm talking about the photon. These fundamental bits of the universe are the very essence of light, and they behave in ways that are so strange, so counterintuitive, that they make you rethink what it means to be real. They are the ultimate cosmic tricksters, and trying to pin them down is one of the most fascinating challenges in all of science. Consider this. The mystery of the photon is a bit like trying to solve a cosmic whodunit. Scientists, brilliant people in lab coats, have been scratching their heads for decades, setting up elaborate experiments just to catch a glimpse of a photon's true nature. But here's the funny part. The very act of looking at them seems to change how they behave. It's as if they're camera shy. Imagine trying to take a picture of a friend who freezes into a stiff pose the second they see a lens. That's a photon for you. This isn't just a quirky habit. It's a fundamental rule of the quantum world, a place so bizarre it makes science fiction look like a documentary. This personality shift is at the heart of quantum mechanics, and it's what makes photons so incredibly cool. They force us to ask some really big questions. What is light? What is reality itself? Are things only there when we are looking at them? These aren't just philosophical musings. They are questions that physicists grapple with every single day in their labs. The photon is a constant reminder that the universe is far more wondrous and weird than our everyday experience might suggest. It's a tiny, massless messenger from a realm where the rules we know and trust simply don't apply. And that is just awesome. So let's get ready to dive into the world of this amazing quantum character. We're going to explore what a photon is, how it pulls off its incredible disappearing and reappearing act, and how these little bundles of energy are responsible for almost everything you see around you. From the screen you're reading this on to the warmth of the sun on your face, photons are the unsung heroes of the universe. They are the artists painting our reality, even if they get a little shy when we try to watch them work. Science is cool, so what in the world is a photon? Let's start simple. Imagine you want to send a message across town. You could hire a courier to carry a single sealed envelope. In the universe, light works in a similar way. A photon is like that courier, but instead of carrying a letter, it carries a tiny, specific amount of energy. It's a little packet, a discrete bundle of light. Albert Einstein was one of the brilliant minds who figured this out. He realized that light doesn't just flow like a smooth, continuous river. Instead, it travels in these individual quantized packets. Each one is a photon, a single unit of light on a mission. These energy packets are truly remarkable. First off, they have absolutely no mass. Zero, zilch, nada. That might sound strange because how can something exist without having any mass? Well, photons are pure energy, constantly in motion. In the vast vacuum of space, they travel at the fastest speed possible in the universe, the speed of light. That's about 300,000 kilometers per second, or 186,000 miles per second. They are the ultimate cosmic speedsters, zipping across galaxies for billions of years without ever slowing down or getting tired. They are born from an event, like an electron dropping to a lower energy state in an atom, and they travel until they are absorbed by something else. Now, when we say light, most of us think of the colors we can see, like in a rainbow. But that's just a tiny sliver of what's out there. Photons make up the entire electromagnetic spectrum. Some photons have very little energy, and we experience them as radio waves, which bring music to your car. Others have a bit more energy and become microwaves, perfect for heating up last night's pizza. Then you have infrared visible light, ultraviolet, which can give you a sunburn, X-rays, and the super high-energy gamma rays. They are all photons, just with different energy levels, like couriers carrying packages of different sizes and importance. So, to put it all together, a photon is a massless fundamental particle that travels at the speed of light and carries a specific amount of energy. It's the basic unit for all forms of electromagnetic radiation, from the long, lazy radio waves to the powerful, energetic gamma rays. They are the building blocks of the light and energy that fill our universe, constantly streaming from stars, galaxies, and even the light bulbs in your home. They are the messengers, the movers, and the shakers of the cosmos, all packed into a tiny, energetic bundle. Here's where things get really, really weird. And by weird, I mean fantastically, mind-bogglingly cool. Scientists discovered that photons have a serious identity crisis. They can't seem to decide if they want to be a particle or a wave. Think about it this way. A particle is like a tiny little ball. You can throw it, it hits a specific spot, and it exists in one place at one time. A wave, on the other hand, is like a ripple in a pond. It's spread out, can go through multiple openings at once, and can interfere with other waves, creating bigger or smaller ripples. These two things seem completely different, right? Well, a photon is somehow both. This is called wave-particle duality, and it's a cornerstone of quantum mechanics. Sometimes, when scientists set up an experiment to measure a photon as a particle, that's exactly what they see. For example, when a photon hits a digital camera sensor, it activates a single pixel, thwack, just like a tiny ball hitting a target. This particle-like behavior is predictable and solid. It's the photon acting like a well-behaved little courier delivering its energy packet to one specific address. So far, so good. No big mystery here, right? But hold on. If scientists set up a different kind of experiment, the photon's other personality comes out to play. The most famous example is the double-slit experiment. If you shoot a stream of photons at a barrier with two thin slits in it, you might expect to see two bright lines on the screen behind it, corresponding to the slits. But that's not what happens. Instead, you get a whole pattern of bright and dark stripes called an interference pattern. This is classic wave behavior. It's as if each photon passes through both slits at the same time as a wave and then interferes with itself. How can one ball go through two places at once? This is the part that drives everyone bonkers. The moment you try to watch which slit the photon goes through by placing a detector at the slits, the wave pattern vanishes. Suddenly, the photons behave like good little particles again, going through one slit or the other, and the interference pattern disappears. It's as if the photon knows it's being observed and instantly snaps back into its particle disguise. This isn't a trick. It's a fundamental property of our universe. The act of measurement forces the photon to choose a state, collapsing its wave-like possibilities into a single particle-like reality. You might be thinking, okay, this quantum weirdness is cool, but what does it have to do with me? The answer is everything. Photons are not just some abstract concept in a physics textbook. They are working for you all day, every day. Let's start with the most obvious example, the sun. Our star is a gigantic photon factory, blasting out an incredible number of them every second. These photons travel 150 million kilometers through space, and about 8 minutes later, they arrive at Earth. Some warm your skin, some provide the energy for plants to grow through photosynthesis, and some bounce into your eyes, allowing you to see the world around you. But the fun doesn't stop with sunlight. Take a look at the technology you're using right now. The screen of your computer, tablet, or phone is lit up by, you guessed it, photons. Whether it's an LED, LCD, or OLED display, it works by generating or controlling tiny little photons to create the images and text you see. And what about lasers? A laser is just a highly focused, organized beam of photons that are all marching in perfect step with each other. This coherence allows them to be used for everything from scanning barcodes at the grocery store to performing delicate eye surgery or cutting through steel. Every time you see that little red dot, you're seeing photons on a mission. Let's consider another powerful example: solar panels. A solar panel is essentially a photon catcher. It's made of special materials, usually silicon, that are designed to absorb photons from the sun. When a photon strikes the panel, it transfers its energy to an electron, knocking it loose. This flow of freed electrons is what we call electricity. So, every time you see a solar panel powering a home or a streetlight, you're witnessing the direct conversion of light energy into electrical energy, all thanks to countless individual photons giving up their energy packets for a good cause. It's a beautiful and practical application of quantum physics at work. From the fiber optic cables that bring high-speed internet to your home to the camera on your phone that captures photons to create memories, these little light particles are the invisible engines of our modern world. They cook our food in microwaves, They let us see inside our own bodies with X-rays, and they carry the radio signals that let us listen to our favorite songs. So, the next time you switch on a light or feel the warmth of the sun, give a little nod to the humble photon. It's doing a lot more for you than you might think. The unseen show. So we've been on quite a journey. We've learned that photons are like tiny, massless couriers of pure energy, traveling at the universe's ultimate speed limit. They come in all different energy levels, making up everything from radio waves to gamma rays, far beyond the sliver of light our eyes can perceive. These little packets of light are the fundamental particles that paint our reality, delivering the energy that warms our planet, powers our plants, and allows us to see the beautiful world we live in. They are, without a doubt, one of the most essential building blocks of the cosmos. We've also dipped our toes into the wonderfully weird world of quantum mechanics, where photons reveal their dual personalities. They are the ultimate shapeshifters, behaving like a focused, definite particle one moment and a spread-out ethereal wave the next. The famous double-slit experiment shows us that a single photon can act as if it's in multiple places at once, creating patterns that defy our everyday logic. And most bizarrely, the very act of observing a photon forces it to abandon its wavy, mysterious nature and snap into a single, measurable state. It's a cosmic magic trick that scientists are still trying to fully understand. From the practical to the profound, photons are everywhere. They are the workhorses behind our technology, powering our solar panels, lighting our screens, and carrying information across the globe in the blink of an eye. Every laser beam, every photograph, every bit of warmth from a fire is a testament to the power and presence of photons. They are not just abstract ideas, they are tangible, in a quantum sense, parts of our daily existence. Understanding them is key to understanding how so much of our world, and the universe itself, actually works. They are the messengers and the message, all rolled into one. And this brings us back to that tantalizing final question. If a photon only chooses to be a particle or a wave when we are looking at it, what is it doing the rest of the time? When no one is watching? When no detector is set? What is a photon really up to? Is it a swirling cloud of infinite possibilities? Is it a wave peacefully rippling through space-time? Or is it something else entirely? Something our human minds haven't even conceived of yet? The unseen show of the universe is constantly playing out, and the photon is its star performer. What do you think it's doing right now?